My name is Tatiana Chibisova, and I present you my project Smart House System on DE10 Nano. The development object is a hardware and software complex for the device management and access system management for the smart home system. The project is divided into components: a neural network for facial recognition, a server, a mobile application for Android, a control system for DE10 Nano modules. Implemented a mobile application that supports communication with external devices to 10 Nano. The communication applications and the 10 Nano created the server, dispatching requests to switch on the devices. Added face registration to provide additional functionality, smart lock. Developed and trained neural network that allows you to determine the registered user. The project consists of a server with a neural network for face recognition, an Android mobile application, and a DE10 Nano board. For work, a certain logic of component interaction is used. Each new user needs to download and install a mobile application on their smartphone. When using for the first time, you need to register. To do this, select the corresponding button on the application start page. To register, you must specify a username and password. Then the application will offer to go through the process of initializing the face by scanning the face through the front camera of the smartphone. In the future, to enter the application will be used previously set login and password. After authorization in the application, the user enters the main screen with a list of devices available for management. The list of devices is limited by the access rights of each individual user, and can be expanded or changed from the administrator account. A request to enable the selected device is sent to the server, where it is processed and then transmitted to the DE10 Nano. The request received from the server is interpreted on the DE10 Nano as a call to the module corresponding to the sensor to receive data. If the device must transmit data, such as temperature, humidity, then the FPGA received it sends it back to the server, and from there back to the user device. In addition to devices operating at the request of the user, there is a smart lock, the operation of which is based on the following logic. A smart lock consists of a motion sensor, a distance sensor, a USB web camera, a servo drive, 2 diodes. The hardware part of the project consists of a server organized on the basis of the computer to which the camera is connected, DE10 Nano boards to which smart lock is connected, HCSR04 rangefinder sensors, DHT11 temperature and humidity sensor, MG90S servo drive, SR505 motion sensor, indicator LEDs and relays. To communicate with the DE10 Nano server, a WAT connection module was implemented, consisting of an RX module for receiving data by the FPGA card and a TX module for transmitting data. The baud rate can be set to the following values: 9600, 19200, 38400, 57600, 115200 baud. The SR505 motion sensor, when motion is detected, returns a 5 volts digital signal, so a dog-level converter from 5 volts to 3.3 volts was used to connect it to the DE10 Nano. For the HCSR04 rangefinder sensors, a module has been developed that implements the following actions. First, a high signal level is applied to the trig sensor contact for 10 microseconds to generate an ultrasonic wave. Then there is a wait when a high signal level does not appear on the echo pin of the sensor, and the time is counted until the signal applies a low value. Further, to translate the obtained value into the distance to the obstacle in centimeters, the obtained value is multiplied by a coefficient of 0.01723. To work with servo drive, a frequency divider module was implemented, which receives a 50 MHz clock signal at the input, and generates a clock signal with a frequency of 26 kHz at the output. At this frequency, a PWM signal of the required duty cycle is generated. Thank you for your attention.